Alrighty, in this video we are going to be talking about related rates. We're going to be doing problems 3 and 4, aka the ladder problems. Now, whenever we're talking about related rates, we want to obviously read the problem very carefully, draw the diagram if possible. We're going to write down everything we know, so we're going to introduce some notation, assign symbols to all quantities that we know. We're going to express the given information and required rates in terms of its derivatives. We're going to write an equation that relates the various quantities. We might need to use geometry. In these problems we won't, but in the shadow problem and the cone problem we will in the upcoming videos. We're going to use chain, and then after using chain, we're going to solve for the unknown rate. All right. So, looking at number 3, we have a 16-foot ladder that is leaning against a wall. That's what I'm going to draw right now. I have a 16-foot ladder. And the bottom of the ladder is 5 feet away from the wall at time t is equal to 0, and slides away from the wall at a rate of 3 feet per second. We want to find the velocity at the top of the ladder at time t is equal to 1. All right. So, notice how the bottom of the ladder is 5 feet from the wall at time t is equal to 0, but we don't want that. We want t is equal to 1. Since we want t is equal to 1, and I know that the bottom of the ladder is sliding away from the wall at a rate of 3 feet per second, I know that my horizontal height is going to be 8 here. So, let's see what I know. I know that x is 8, don't know what y is, and I know that z is 16. I also know that dx dt is 3 feet per second. And we're trying to figure out what dy dt is, since we're talking about the velocity at the top of the ladder. So that's what we're trying to find. So now we need to think, okay, how do we find out what y is, and how do we find out what dz dt is? To find out what y is, we're just going to use good old Pythag, using 16 squared minus 8 squared and call it a day. So if I do that, that's going to be 192 as our height. Root 192. All right, now what I'm going to do is think about dz dt here. And I'm going to show you a little applet in terms of problem number 3. As I move the ladder here, notice how my x is changing, dx dt is changing, and my height is changing, dh dt is changing. Notice how what's not changing, though, is my ladder. It's still going to be 10 feet no matter what in this scenario. So looking at my problem on number 3 here, my ladder is still going to be 16 feet no matter what. As I move from the right here, and as I move down here. So what dz dt is just going to be 0. All right, so I know what x is, I know what y is, I know what z is, and I know its derivatives. So what we're going to do is think about an equation that we use that combines everything with this mess right here. Notice how we found y using Pythag. So that's what we're going to be using as our main equation. So we're going to have, let's see this in green. We have x squared plus y squared is equal to z squared. And then we're going to take the derivative of this. So 2x dx dt, 2y dy dt, 2z dz dt. I'm going to go ahead and eliminate the 2's. And then I'm also going to get rid of the dz dt and the z, because we know that the ladder is not going to change. It's still going to be 16, aka 0 feet per second. So this means that my whole right side is going to be 0. All right, we want to find out what dy dt is. So I'm just going to plug in everything I know. I know that x is 8 feet. dxdt is 3 feet per second. Y is root 192. And we want to find out what dy dt is. Notice how I have my units. The reason why is because I want to show you guys how the units are going to cancel out. I'm going to solve for dy dt, which means that I'm going to subtract the 8 and the 3. That's going to be 24. Negative 24 feet, and then feet per second. And then I'm going to divide by root 192 feet. If I divide by root 192 feet, you'll notice that the feet will go away, and I'm left 12 feet per second, which is what we want as my rate. So then I have dy dt being negative 24 over root 192 feet per second as my unit. Now, notice how our answer is negative, which makes sense in context because our ladder, our height, is always decreasing. It's falling down. Since my height is falling down, that's one way for us to check that our answer is going to be negative. All right. Number 4 is another ladder problem, except this time we're not going to be finding the velocity. We're not trying to find dHdt. Instead, if we were to read it, we want to find the angle, how fast the angle between the top of the ladder and the wall is changing when the angle is pi over 4 radian. So we're trying to find out the angle. All right, so let's look at my problem. We have a ladder that's 10 feet long that rests against a vertical wall. The bottom of the ladder is sliding away from the wall at a speed of 2 feet per second. So let me go ahead and jot down what I know. I know that z is 10 feet, and I know that dxdt is 2 feet per second. That's it. I don't know what dy dt is. And of course, I know that dz dt is going to be 0 since my height of the ladder is never changing. I don't know what x is and I don't know what y is. So we're just going to leave her like that, x and y. And of course, we do know that theta is pi over 4. And we need to figure out what d theta dt is. All right. Based off of this information, we want to make an equation that has theta, has z, and has x. I'm not going to use y because I don't know anything about her. She is mysterious. We have y, we don't know anything about y, and we don't know anything about dy dt. So whenever we're making our equation, let's think about x and z, and let's think about theta. Now, I haven't put where theta is, but notice how it says that it's between the top of the ladder and the wall. So theta is going to be right here. Okay, if she's right there and we want to figure out an equation in relation to x and z, x is my opposite and z is my hypotenuse. So thinking about opposite and hypotenuse, that's going to be sine. So I'm going to have sine of theta is equal to opposite over hypotenuse. My equation, okay, we already found her. Great. Now we're going to take the derivative. So we have cosine theta d theta dt is equal to 1/10 dx dt. And now at this point, we're just going to plug everything we know. All right. And we want to find out what d theta dt is. So we know that theta is pi over 4, which means that we have cosine pi over 4 d theta dt is equal to 1/10. And we know that dx dt is 2 feet per second. Let me go ahead and give you this. The 1/10 was, let's see, 10 was feet. This is going to be feet. All right, so what we want to do now is get rid of cosine pi over 4, because we know that that's just going to be root 2 over 2. Now remember that root 2 over 2 is a radian. So then if I do d theta dt, I'm going to have, let's see, 2 root 2 radian, and then 1/10 10 feet, and then 2 feet per second. Now, if I do that, notice how the feet will cancel out because it's 10 right here, which means I'm only left with let's see, 2 root 2 radians. Oh, let me do this. 2 root 2, and then I have a 2 10 that I have radians per second. So this right here is going to be my final answer. If I wanted to keep this, simplify this even more and make it a little bit prettier, this is 1/5. So I have 2, and then root 2 times 5 radians per second. Now, obviously, you could just leave it as this right here and call it a day. Don't simplify if you don't need to, all right? But that was number 4. All right, in the next video, we'll talk about area and volume using circles, and then we'll look at a cone problem and the shadow problem.